Hello everyone, today we are back with another question from LeetCode. This is a medium level dynamic programming related question. I'll quickly jump into the problem statement that we have. So we are given a code in this format, and we have basically assumed that all the alphabets in English are numbered. So A is 1, B is 2, C is 3, and D is 4 in this fashion. So basically we have to tell for the given code how many ways we can decode it. So we can see here we can decode it in these two ways. One is taking 1, the other is taking both first one and then the pairing these two and taking 6. So basically if we consider just one, then it will be A, then we consider just the other one, that will be A again. Then we consider this 10, then it will be J, and 6 is F. So in this way, but what if we take this both one together? In this case, it will be K, and again this 10 will become J, and then this 6 will become F. We have to make sure one thing, like if there is a 0, we have to pair it with someone before that. Okay, so there is no option in which we cannot pair it with something, because zero doesn't it does zero alone is nothing, so it doesn't map to any of the alphabet. Similarly, let's say if there is 3 and 0 in the long code, we have 3 and 0, then that particular code becomes invalid, because if we pair 0 with 3, 30 doesn't map to any of the alphabets, so even that is invalid. So this is the scenario we have. So what we have to do is, there is simple approach. I'll just quickly explain what is the recursive way to do it. So let's say we have a solve function. In that solve function, we pass 0. So because we are starting from the uh, first integer. So there are two things we have to do. We have to see whether the current integer plus the next integer, is it below 26, below or equal to 26. We are doing this just to make sure that that the pair is also a valid code. For example, if it was 27, this doesn't map to any of the alphabet, so this is not a valid code. So if it is equal or below 26, then we have to call solve twice, that is solve with I and plus solve with I plus 1. This we are doing because we are assuming that in this code, once we are taking just one as a as the letter, so that will map to A. But since 1 and 1 also form a valid pair, that's why we are also calling the solve function with I plus 2. Because when we are considering this pair, we have to start evaluating this particular I. Okay, so we are basically skipping the I over here. So that's what we are doing. So if it is less than or equal to 26, then we are first taking just the current number, that is 1, and then we are taking both 1 1 and start evaluating the next one. So that's why uh, it's not I plus 1, it's I plus 1 and I plus 2. So basically we are either moving to the next number or moving to the next to next number. So but in case where it is not forming a valid integer, like let's say if it is 31, and we in a long sequence of numbers 1 2 5 3 1 6 7, so we are here. So since 31 is greater than 26, so we are not going to follow this, like we are not going to take 3 1 3 ones and then 31 ones, because 31 doesn't form a valid pair. So what we are going to do is, we are simply going to take just one value 3, and we are going to next integer. We'll not take both the values and jump to the next integer. So this addition or calling the same function twice won't make any sense. So we'll just make call solve I plus 1, simple as that. So this is there. Now in the break condition, what we can do is, we can simply, if we reach beyond the length of a string or length of the code, we are at the end, then we simply return 1. That simply means that we have uh, we have formed a valid pair, valid code. And but there's also one thing, like let's say if while jumping 1 2 3 0 4 6, we are forming the pair, we take 1 2, okay, we take 1, we take 2, that is also fine. Then for 2 we take just 2, just 3, that was fine. We also took 2 3, but after taking 2 3, where did we jump? We jumped to 0. Okay, so that's basically saying we took 1, that was A, we took 23, that is whatever, uv or something, and then we take 0. Since we reached 0, and 0 itself is nothing, it's not forming any valid code, that's why we have to return 0 from here. So we simply have to return 0, because proceeding in this manner should not give us any result. That's what you can see in the code. If we have reached, if the current I reaches the 0, we simply return 0. So that's what we have to do. And if we are at the end of the string, then we return 1. And yeah, so this is the case if we are at the second last element, then also, yeah. So there was one more thing, like let's say if we have reached for this particular code itself, 11106, if we have reached here, so we don't have to pair it with anything next to it, because there's nothing next to it. So we just simply have to call solve I plus 1. The I plus 1 will make it reach the end of the string, and we will reach here, I equals to length of s, and we'll return 1. So that's what we are doing. And in case it is less than 26, you can see we are simply calling both the functions with next letter and next to next letter, and we are returning and we are also performing a memoization for the same. So li uh, is a dictionary. So what we are basically going to do is, for repetitive solutions, we are going to store all the values. For example, like let's say 1 1 2 3 4. So we let's see in how many ways we reach 3. So once we take 1, then we take 1 1, and for this particular one, we also take 1 2, and we reach 3. But for this particular one, we also take 1, then 1, then 2, and then we reach 3. So you saw, right, we reached I equals to 0 1 2 3. I equals to 3 in two ways. We reached it by taking single pairs. We reached it by taking 11 11 2, and then 3. We reached there by taking a 1 uh, 1 12, and then 3. So there are many ways we are reaching 3. So basically what will happen is, this particular function, that is 3 0 1 2 3, where value of I was 3, is called more than 1. And it, since it will be evaluated every time, so what we do is, as soon as we get it evaluated for the first time, we recreate a dictionary, and at the position 3, at the key 3 of the dictionary, we store the value whatever is returned by the the further function calls. So that, for example, in 1 1 1, the next 3, when we reach here, whatever was evaluated, let it be evaluated, we get some value, let's say 5 or something. Then next time when we pair 1 1, then 2, then we reach 3. So we don't have to evaluate this solve I equals to 3 again. We just have to see whether the value exists in li 3 or not. If it exists, then we simply return that uh, particular element in the dictionary. So that's what we have implemented. And yeah, this passes all the test cases. So basically the approach here was um, bottom up approach or top down approach using memoization. So without memoization, we are crossing the time limit, because there are many repetitive calculations for the function. So yeah, thanks a lot for following till here. Thank you.